Hello and welcome to today's SEI webcast, Developing Models to Support DoD Technical Reviews. My name is Shane McGraw, Outreach Team Lead here at the Software Engineering Institute, and I'd like to thank you for attending. We want to make our talk today as interactive as possible, so you can submit your questions in the YouTube chat area now, and we will get to as many as we can. Our featured speakers today are Julie Cohen, Rob Wodzik, and Linda Parker Gates. Julie has been at Carnegie Mellon University Software Engineering Institute for over 15 years. She supports works on the software acquisition pathway, acquisition strategies, and metrics. Rob is also a senior member of the technical staff at the SEI, a position he has held since 2004. In his current position, he performs training and consulting in software architecture technology and related practices. Linda leads the Software Acquisition Pathways initiatives here at the SEI in our Software Solutions division. She specializes in strategic planning, change management, technology transition, and performance excellence. Now I'll turn it over to Linda Parker Gates. Linda, welcome, all yours.
Thank you, Shane, and hello, Julie and Rob. Thanks for joining us. Can you tell us what we're going to be talking about today?
So today we're going to be discussing our investigations into developing models to meet data item description or DID information requirements, and also developing models to support DoD systems engineering reviews. The work was initiated by a customer who wanted to move towards digital engineering and greater use of modeling, but they wanted some guidance on how to replace the current process in which the artifacts were produced and reviewed at the major program milestones using more modeling. Now the DIDs, for those who don't know what DIDs are, these are standardized documents used throughout the Department of Defense that defines what types of documents the programs will need at various stages in the entire system development lifecycle. They define artifacts in terms of the information they should contain, their intended use, and to some extent their format depending on the DID. The artifact typically produced in response to a DID is a document, and it meets the DID's requirements and the intended use.
Okay, our initial investigation focused on how to develop models to meet DID information and intended use requirements for individual DIDs, like for one DID at a time, and to use those models as a replacement for the typical artifacts that a contractor would normally deliver in response to a DID. And normally those, it's very typical for contractors to respond to a DID with some kind of document artifact, like a Microsoft Word document or that sort of thing. So we did a lot of initial investigation, and some of our key findings, we found that the information requirements in DIDs were at varying levels of abstraction. So if you looked in a particular DID, you might see the DID asking for information that would be at a very high level of abstraction. Or you would look at the same DID and see the DID asking for really low-level detailed information. So for example, the subsystem specification DID. If you look through that DID, you'll see that it's asking for high-level capability descriptions, and on the same hand, the same DID is asking for very low-level details, excuse me, of record and message formats. Second thing we found in our investigation is that the DIDs often overlapped in information. So again, if you looked at the subsystem specification DID and you looked at the system requirement specification DID, you would see that the two DIDs were asking, in a lot of places, asking for the exact same information. And the third thing, which I think is pretty key to what we discovered, is that first of all, it's possible to model anything. It's possible to model all the information that a DID is asking for. I think one of the bigger challenges is to decide what exactly to model and how to go about modeling things. A very important thing we discovered from our initial investigation, it's very difficult to take a DID and decide what to model and how to model it unless we know what is the purpose of the model and what is the target audience for the model. It's just like reading a book or writing 101. You always want to identify what is the purpose of the document you're writing and who's the intended audience. And that's the same thing with modeling. You really need to know what's the purpose of the model and who the target audience is to figure out what to model and how to model it. So eventually we took a step back and revised our goal. Instead of focusing on modeling to meet individual DIDs, we shifted our goal to producing models that would provide people with information they need to successfully complete various program events. By focusing on different program events, we had a basic set of questions to answer. That gave us a basic set of questions to answer, which would be, what events do we want to support using modeling? What are the purpose for those events? What information do people that are attending those events want to know? What questions do they want to get answered during those events? And given the purpose and the attendees, how should the information best be modeled to support the event and the attendees?
So Rob, that's really interesting. You know, my background is in, one of my degrees is in architecture, the building kind. We do a lot of model building. Architects do a lot of model building, but it's a very tactile kind of model. But you know, the same kinds of things apply, like what you're talking about, right? You build a model to explore different relationships, or, you know, in architecture, maybe materials or sight lines or something like that. But the context is pretty critical to determining what you're going to model and what parts of the system or the thing you're going to model. So can you tell us, one of you tell us the process you used to build the guidelines that you developed?
Sure, I can do that. We were limited, unfortunately, by both time and funding. So we started by selecting a small number of key life cycle events. So the ones that we looked at were the system requirements review, the system functional review, the software specification review, the preliminary design review, and the critical design review. We established the purpose for each review, along with what types of stakeholders would attend each type of review. The next thing we did was we looked at what information those stakeholders would need to know and what they would want to have answered, what types of questions they'd need to have answered during those reviews. After that, we used the information that the stakeholders would need to know and the questions they'd want to have answered to identify very distinct types of information that were needed to support the reviews. And then, given the purpose and the types of stakeholders, we identified ways to model the various types of information that they would need.
So can you go deeper into that and tell us how you determined what kind of information these event stakeholders would need to know and what questions they'd want to have answered during the reviews?
Sure. Well, we looked at several different sources, including the Navy's NAVAIR Systems Engineering Technical Review Handbook. We looked at DAU checklists and a few other sources. And we looked at the types of questions those sources said would need to be answered and developed what information we thought we would need to be answered, would be needed to answer those questions. So if you look at the slide, you can see a sample of the SRR questions, and I think there were over 100 questions just for the system requirements review alone. So we did a very extensive job of developing those lists of questions.
Well, so then how did you identify the specific information you would need to answer those questions? And maybe can you give us some examples?
I'll take that. So we did look at an awful lot of questions. I mean, as Julie mentioned, there were, just for the SRR alone, there were over 100 questions, plus, you know, types of questions that SRR participants would want to ask. So an example might be, during an SRR, An example question would be, is the developing contractors requirements baseline traceable to the government's requirements baseline? So we ask ourselves, okay, to use models to determine whether or not the contractor's requirements baseline is traceable back to the government's requirements baseline, what kind of information do we need to answer that question? Well, we need to know what are the government's baseline requirements. We need to know what are the prime contractor's baseline requirements, and we need to know associations between those requirements. So given a government requirement, we need to be able to trace forward to the contractor's system requirements. And given a system requirement, we need to be able to trace backwards to the government requirements. So we did that kind of analysis for every single question. You know, we looked at each question. We said, okay, what information do I need in a model to be able to answer this question? And so based on that analysis, the first pass was to take each question and identify just what types of information do we need to answer the various questions. And so what you should be seeing on your screen now is an example of the types of information that one might need to achieve the goals of a system requirements review. And you're seeing kind of a small sampling here. That's why the last little bullet on the slide says ETC. There were an awful lot of types of information that were potentially of interest. So once we identified the types of information, we looked at each type and we said, okay, what specific information from each type is needed? So let's take an example. Any of the types that you see here that has requirements on the end of it. So let's take software requirements. We zeroed in on software requirements, for example, and we said, okay, we know we need to know about software requirements, but what specifically do we need to know about software requirements? So for the requirement type, we said, okay, at the very least, we need to know, we need to give each requirement an ID number to uniquely identify it. Each requirement has to have a description, and there's some other information that's potentially of interest, like categorizing the requirements, rationale for the requirements. We also want to see what are the associations between, say, government requirements and other government requirements. We also want to see the associations between contractor system requirements and other contractor system requirements. And we also want to see the relationships between government requirements and system requirements. So everything you see in this table that's marked yes, we considered it to be absolutely essential to include in a model. The other information that you see listed in the table with a little dash in the essential column means it would be nice to have, but we don't consider it to be absolutely essential to satisfying the purpose of an SRR.
So in order to build these models, how did you go about identifying the various ways to model all these different kinds of information that can be needed?
So I can answer that one. First, as Rob said, we partitioned the types of information needed into essential and non-essential. So some was absolutely needed and others was nice to have, but you could live without it and likely satisfy the goals of the review. And what you're seeing now is we looked, so let me back up just a minute. As I said before, we were limited by both time and funding. And so when we got to the modeling part, while we developed questions for all of those reviews I mentioned earlier, when we got to the modeling part, we focused on SRR and SFR, and that was as far as we got in this particular effort. So you'll see in this table, the same types of things you saw in the last one. And then we talk about which reviews that information is essential. And then we give a descriptor. So that started to give us the information that we would need to start to create those models. And I'll let Rob pick it up from here.
Okay. So after we identified essential and nice to have information, then we started to zero in on developing guidelines. Actually, we did the guidelines for both the essential information and eventually we provided some guidelines for the non-essential information. We also, when it came to providing modeling guidelines, we also partitioned the world into guidelines for modeling techniques to use, modeling languages and frameworks that one might consider using, and also modeling tools. The modeling techniques category itself was partitioned into structural techniques, modeling techniques, behavioral modeling techniques, and associational modeling techniques. We then matched the different types of information needed in a model to the modeling techniques, the languages and frameworks, and the modeling tools. So, so what you're seeing on the screen now is, oops, if you go back a slide for quickly. So you're seeing for SRR, you can see down the left-hand column, we're saying, okay, what types of information is needed in the model? Well, we see we want to have government requirements in the model. We want to see the various system use cases in the model. We want to see operational use cases and so forth. That table is actually much bigger than the snippet that you're seeing here. Then moving down to the next slide, please. Then we started to look at all the different types of information needed and the specific information needed. And we said, okay, what are the best modeling techniques to use? Not necessarily the best. There's all kinds of different ways to model a piece of information. So this is more of, what are the viable options for modeling different types of information? Okay, so you see different behavioral modeling techniques, different structural modeling techniques, and so forth down the modeling techniques column. And then going across the top, you see modeling frameworks that could potentially be used, languages, and modeling tools. And the X's in the green mean that the language, the framework, or the tool directly supports the modeling technique listed in the modeling techniques column. Yellow means you could do it with the framework, the language, or the tool, but the framework, language, or tool doesn't have anything explicit that supports that particular technique, and so forth. So the colors are kind of giving you an indication of the level of support that any particular framework, language, or tool has for any particular modeling technique.
So, before we move on to some of your observations about this work and how it, how the two kinds of modeling versus the DID documents compare, we do have a question from the audience that I want to take. So Sundar asks if you will touch on incremental model-based systems engineering toward meeting the reviews. And he clarifies, I'm talking about how agile MBSE might be used to meet the tech review needs of the DoD. Do you have any thoughts on that?
I can tell you that I think it's a good idea. I can't say that I've done a lot of reading on the idea of agile and model-based systems engineering. I can tell you I'm guessing that it's very applicable, especially since one observation from doing our investigation throughout is that a lot of information is just not available or it's not even appropriate to have at a given point in time. So for example, if you were to read through the subsystem specification DID, well, there's an awful lot of information that's being asked for there. As I mentioned before, from a very high level of abstraction to a very low level of abstraction. And first of all, when you're going through the DoD life cycle, well, a lot of that information is not immediately needed. So for example, in an SRR, I'm trying to verify, one of the key goals of an SRR is to verify that the contractor has adequately understood the government's requirements and has formulated those requirements into some viable system requirements. So it's probably more often than not, I don't need to have a very low level details of the requirements of record formats and message formats to satisfy the information requirements for a system requirements review. So if I don't need it, I don't want to model it. And on top of that, I might not even know what those things are at the time of SRR. So we kind of became aware more and more that the models are definitely going to evolve over time. They're going to start off having a little bit of information in the model at the beginning and slowly evolve over time to add more information. So the model that you see supporting an SRR, there's going to be a lot added to it by the time you get to PDR and CDR to adequately support PDR and CDR. So I imagine that Agile, combining Agile with modeling is probably a really good idea and an absolutely necessary idea. Sorry for the long-winded answer.
And I would also add that if your entire development is following an Agile methodology, then as you start to build those models, you don't have to wait for a review to see what's been added to a model. That as the contractor is continuing to add to the models at various parts of the development, the government can follow along with what is being added, versus the old way where you got an artifact based on a DID, and you got one document for one review, and then for the next review, you either had to look at track changes or try and look to see what changed between two documents, and it wasn't nearly as easy to follow along with how things were developing incrementally. And so by using modeling and by not just looking at it at each review, but by following an Agile methodology and following the changes as they happen, you can spot things that might be an issue or that might be of a concern to the government much earlier. So doing this in an Agile fashion really provides real dividends.
Great, thank you. And thanks for the question. So can you talk a little bit about the overall differences that you found between the traditional way of meeting DID requirements and your efforts to try to meet those requirements using models?
Certainly. The data item descriptors, for the most part, were written before the widespread use of model-based engineering. And some of those are now being updated to take it into account, but there are a lot of data item descriptors out there that were not written to encourage modeling. They mainly provide information on the data that should be provided in the document, but oftentimes they're silent on the format. They can tell you what the format is, but oftentimes the government instructions are to use the contractor format. They also describe specific artifacts one at a time, whereas you typically want to see things that are interconnected. And so your models will let you see those interconnections, and they can reflect the entire system and not just one tiny little part of the system. So instead of delivering artifacts based on 10 or 20 DIDs for a PDR, you might deliver 4 or 5 interconnected models that would allow you to answer most, if not all, of the technical questions that need to be answered during that review.
Well, that aligns really well with my architecture example. right? Because you can look at plans, but it's when you pop up the model that you can start to see what those sight lines or relations between what you're building to what's already on the site or something like that. So yeah, that's really interesting. Thanks. So what do you think the benefits are of providing modeling guidelines for these DoD technical reviews?
I'll take that, Julie. So modeling to support life cycle events offers a number of potential benefits. And as I mentioned before, it's really important when you're writing a document or when you're developing a model to understand exactly what is the purpose of the document or model and who's the target audience. So by focusing on life cycle events, it's each event that's giving us a purpose for the modeling that we're doing, and it's giving us a target audience. And I want to make sure that I'm making myself clear about this point. So for example, I could have the greatest model in the world, the most detailed model in the world, using some very formal mathematical looking notation, and the model's completely accurate. It says everything I want it to say, but then I turn it over to somebody. If the person I turn the model over to can't read the model because they don't understand the modeling language that I'm using, well, the model's says everything it's supposed to say, but nobody can read it. So by focusing on the life cycle events, it tells us why are we modeling, and it tells us what are the types of people that are going to be looking at the model. Then I can select modeling techniques that are most appropriate. You know, if I'm doing a model for developer types of people, well, my model is going to look completely different than if I'm doing models for upper management. If it's a model for developers, then I'm gonna have models. My models can be fairly technical. If it's models for upper management, then I might limit my modeling to the use of clip art because that's easier for people to understand. They don't have to know any particular modeling language. Okay, so that's benefit number one, I think. Also, modeling to support the events helps us to provide contractors with guidelines on how to go about building models to satisfy contractor deliverables, including guidance for picking the modeling techniques, for picking the modeling languages, and picking the modeling frameworks and tools to use. Thirdly, you can, once we have models in place, you can not only use them to support the different life cycle events, you can also use those same models for assessing system requirements and assessing proposed solutions, and also for assessing the impact of changes later on in the program. And also, any models that you do develop can be used as part of the solicitation process. So those are some of the key benefits.
Yeah, thanks, Rob. We're actually getting some questions from the audience now, so let's go over to those. John asks, what software engineering standard are you, or systems engineer, I'm not sure, what standard you're using for the technical reviews? IEEE 15288.2?
So we
Julie,
actually, oh,
yeah, go ahead,
we
Julie.
actually use the, mainly we use the NavAir guidebook to systems engineering technical reviews. Since this was a Department of Defense audience and that's what the customer was using, that's what we based a lot of our work on.
Great.
Actually, let me throw in a comment there. So we looked at an awful lot of stuff. We looked at the SETR, we looked at ACT notes, we looked in the PMBOK, we looked at all kinds of stuff to understand across all the different sources what is the purpose of these events, and what are we going to pick as the stated purpose of these events, and then who are the key stakeholders in these events. So we didn't just pick one source and say, okay, this is the source that we're going to use for all time. We looked all kinds of different sources, not one particular one.
Thanks, Rob.
But I will say, if we get a chance to continue the work, I think that's a great idea to make sure that we are at least in alignment with IEEE, because not everybody is doing a Department of Defense program. So if we get to continue the work, we'll definitely look at that. Thank you.
So I've got another comment followed by a question for you. Matt underscores the importance of starting with the purpose of the model, which you've talked about a few times. And then he asks if there's a way to respond as the purpose evolves over time, maybe as you go through the project lifecycle milestones. Do you have any thoughts on that?
I imagine so. I don't have any problems with the model evolving. And I think, first of all, there's the information content that a model will have. And so the information content is based on different stakeholder needs. And as you move through the life cycle, there's a lot of different types of stakeholders that you're providing information to. So from an information content perspective, the model has to change, and the information in the model has to change. It has to be updated. It has to be added to, and so on and so forth. So that's just the information content. Now the information presentation, well, that's going to have to be updated too. So one day I might want my model supporting a conversation I'm having with developers, and on another day I want that same model to support a conversation with upper management. So the actual views that you provide of a model is going to be dependent on who are the stakeholders that you're addressing. And as you move through the life cycle, you're going to encounter a lot of different types of stakeholders. So you will necessarily be adding and evolving the views that you're providing of the underlying model throughout the life cycle. I hope that answers your question.
I also would add that it would be very interesting if we could go all the way through CDR, because I think that perhaps some of the X's and the greens in this box might, I'm not sure they would, Rob's a real modeling expert, but they might change a little bit if we looked at, for example, what do the sustainment people need to have in this model to support the entire life cycle after it's fielded. And so if you want your model to be able to go all the way through sustainment, then maybe you pick a slightly different modeling technique so that you continue to add on that type of information more easily, since a lot of the costs are in sustainment. You really need to think about that as you start to determine how you're going to model things very early in the program that will also be needed later in the program. Perhaps you do a different model in the end for that type of information. But unfortunately, like I said, we didn't have the time or the money to get that far, but it would be very interesting to see if what's needed later on in the reviews and later on for the program as a whole, even after the reviews, the types of things that modeling can support later in the life cycle, if that would have made any changes to the things that we did for the first two reviews. So
we've got another viewer asks, have you mapped all the required documents to the data types and specific information needed? He says, I find that a lot of required documents contain common information. Yeah,
I'll start in with that. I think Julie's going to probably have some comments on that too, but I could tell you, so first we started, what is the purpose of an event? Then we started with what kind of questions will stakeholders ask during those events, and what kind of information do they need to know? So when we were developing the questions and we were developing the types of information they needed, we tracked everywhere where we got those questions from and everywhere where we got the different types of information needed. And for example, even with questions, if somebody asked, the question, what is the state of requirements from one source, and we saw the exact same question from another source, we would list the question twice and point to 2 different sources. So we did we also did the different types of information. Where did we come up with, how do we know that stakeholders are going to want this type of information? And I think Jolie will attest to, and I'm sure she's going to say a couple of things about, we looked at a lot of DIDs. There are 50 gazillion DIDs out there in the world. And we looked at quite a lot of them, and we tracked where we were getting our question and information types from. Julie, do you want to add to that?
Sure. So as Rob said, we did look at a lot of DIDs, and you're right. There is a lot of common information required in a lot of DIDs. We started out, I think, looking at 5 specific DIDs and tracing all the overlap in the information that was needed from those DIDs. But as we went on with the work, we also tracked which DIDs would answer those questions and provide that information. So I believe we have a pretty good mapping from the DIDs that would ask for information to what we're actually modeling. Yes.
Great. All right. And audience folks, I appreciate all the questions. We've got one more, and if you have any others, please get them in. But Sundar asks, what are your thoughts on mini technical review events such as mini SSR overtime or mini PDR overtime? Is there an appetite for those in the DoD?
So I can start to answer that. I think it's mixed. I think things are moving that way. Slowly but surely, the DoD is trying to become more agile. I think that they're beginning to see that having these major reviews isn't the best way to do things, that building up slowly, that doing even systems engineering, development work in an agile fashion and doing these small reviews. Maybe you need a capstone review at some point for the higher level management, depending on who has oversight of your programs. But I think that the DoD is moving there yet. Some programs are more ahead than others. So if you're working with a DoD program and you try and suggest that, depending on the program, I think you'll get different answers. But I do think they're moving there, and I do think that that is a better way to go, to try and really work on things incrementally, to try and produce all of your documentation in an agile fashion, producing it in small increments, and the government reviewing in small increments, and then building on what you've done. Rob, anything to add?
No, I think that covers it.
Okay, great. So you published a couple of reports based on this work. Can you tell folks about those?
Sure. We were able to complete 2 papers. They should be posted to the SEI website, hopefully within the next week. One is guidance for tailoring DoD RFPs to include modeling. So that talked about all the different parts of an RFP and where you may want to include language. With respect to modeling, it provides some example language, which is not meant to be cut and pasted, but to be changed for your own specific situation. And then we also did a much more technical paper on modeling to support DoD lifecycle events, which covers SFR and SRR in pretty fine level detail. And Rob, did you want to talk about that paper in any more detail?
Yeah, I'll just say a couple words about it. So the paper modeling to support DoD acquisition life cycle events, we evolved that document quite a few times, and I hope right now that my intent was to drive that document towards a usable document, like to kind of guide somebody step by step through how to pick a life cycle event and say, okay, now I have this life cycle event. The very first thing I need to do is understand what is the purpose of the event. Next is what kind of information are people going to need in their models to support the event. Next, what are the ways to go about modeling that information? So we worked on that document and tried to get it into shape where it would actually be more like a step-by-step guide for that a contractor could take and use it to do their models. So it's hopefully, I mean, how exciting can any technical report be? But at least it's not just a technical report. The intent was to not just have a technical report that you just kind of read through and say, okay, well, what do I do with all this? I have no idea. So let's put the technical report on the shelf. I think both documents provide pretty good guidance, useful, practical guidance on how to do RFPs with relation to modeling and how to do the modeling to address DID information requirements.
Great. So since we have a little time, and before I ask about what next steps might be, Jeremy asks, how do you map strictly hierarchical artifacts like CSCI, CSC onto models that may be more nuanced? Any thoughts there?
I'm not sure I understand the question. Could you repeat the question or reformulate the question?
Well, let me read it directly. He asks, how do you map strictly hierarchical how do you map strictly hierarchical artifacts? And he notes CSCI and CSC in parens onto models that may be more nuanced.
I'm not understanding the question. Jolie, are you understanding that question? Maybe I'm just being slow this morning. Linda, do you have any? Maybe he can re-ask the question because I'm just not following it.
Okay, Jeremy, if you want to rephrase or give us some, some additional insight into the question, I'll look for that in the chat. And then let's see, what I was going to ask is about next steps. And I think we've gotten some really interesting thoughts through the questions that have come through about different directions this can go. But can you talk a little bit about what next steps are that you have planned?
Sure. So let's talk about how far we got and where we left off for starts. So looking at, given the amount of time we had and the amount of money we have, we zeroed in on 5 major life cycle events: system requirements review, system functional reviews, SSR, PDR, and CDR. So so what we did initially was we came up with what is the stated purpose for those 5 reviews. After that, we did the questions analysis and information type analysis for each of those 5 reviews. Then we moved on to providing modeling guidelines, one at a time. So first we did SRR. So we made it from stated purpose of SRR, the questions that people want to answer, the types of information they need, and guidelines for modeling that information. We made it all the way through that for SRR. We also made it all the way through questions through providing guidelines for SFR. We ran out of time and money. So we still need to do, so for SSR, PDR, and CDR, we have everything from questions analysis up through the types of information needed, but we have not produced any guidelines for SSR, PDR, and CDR. So an obvious next step is to pick up the work and proceed with providing the modeling guidelines for SSR, PDR, and CDR. As we complete the work for SSR, PDR, and CDR, we'll certainly update the technical reports as appropriate. I think some of the questions that were asked today, like for example, the relationship between agile and modeling, I think that would be a worthwhile area to pursue. I also think that there's probably quite a few other worthwhile areas to pursue. Julie or Linda, I'm sorry, Julie, did you want to add anything to that?
No, I think you hit pretty much everything. There are also, for those of you who are familiar with SETR events, there are also a couple of other SETR events that we didn't include in those 5. So again, if we had more time, I think we'd probably at least go back and look at those other SETR events and make sure that there isn't anything major in those events that might impact the modeling as well. So that may be one other thing.
Thanks, Julie. So I do have some clarification on the previous audience question. And so Jeremy clarifies by saying that by PDR, a software system is divided into top level systems, next level subsystems, et cetera. And modeling doesn't necessarily follow the same decomposition strategy. So do you have thoughts on how to reconcile that? I believe is the question.
Okay, I'll take a shot at so part of our guidelines, when I say we didn't do any modeling guidelines when it came to PDR, you know, whatever I said, PDR and CDR, whatever, we did a little bit of that. We were, you know, we were looking at PDR, you know, for example, PDR and CDR, and we looked at the types of information needed. And one kind of very high level type is, you know, design information.
Mm-hmm.
And the design information would include various design artifacts like systems, subsystems, subsystems, and the dependencies between those subsystems, and so on and so forth, all the way down, you know, down to the code level. So those are the types of information that one might want to see in a model. And when we were identifying the essential and nice to have information, some of the essential information included the high level artifacts and their relationship to the next level of artifacts and the relationship to the next level of artifacts and so forth. So our modeling guidelines, if we were to take them through to completion, you would likely see that by the time PDR and CDR come around, essential information includes a mapping from systems to subsystems, from systems to modules, from modules to functions, and so on and so forth. When we're supporting a particular event like PDR and CDR, those mappings from high-level concepts all the way down to very low-level concepts, we would consider that to be essential information in the model, and we would provide specific guidelines with what are some of the best ways to do that mapping. I hope that answers your question.
I think it does. I think the heart of the question, it looks like, is whether your guidelines assume a hierarchical decomposition of design. And it sounds like they at least accommodate that, right?
Yeah, I believe they do. Yes.
Excellent. And thank you to the viewer who helped us get to that answer. And thank you, Rob and Julie. So I think with that, I know I look forward to the reports being published and to next steps with this work, but I want to thank you for your time today, and I'm going to hand us back over to Shane. Thank you, everyone.
Thanks, everyone.
Yeah, Julie, Rob, Linda, great discussion today. We thank you each for sharing your expertise. And again, we'd like to thank you all for attending today. We ask upon exiting, if you found value in today's presentation, that you hit the like button and share the archive, as it will be the same URL. Also, you can subscribe to our YouTube channel by clicking on the SEI seal in the lower right-hand corner of the video window. Lastly, you can join us for our next live stream, which will be May 4th, and our topic will be predictable use of multi-core in the Army and beyond, with Bjorn Anderson, Dionisio Denise, and William Vance. Registration information is available on our website now and will be emailed out as well. Any questions from today's event, please send to info@sei.cmu.edu. Thanks, everyone. Have a great day.